Let us discuss about the quantum efficiency of a metal surface. In the previous section, we already discussed that when a radiation beam incident on a metal surface, then it is not necessary that every ejecting photon or every capable photon which will incident on the metal surface which is having photon energy more than work function will eject an electron. Because it may be possible that when the photon is absorbed, electron may lose its maximum energy in the internal collisions and it will not left over with sufficient amount of energy to overcome the work function. Then no electron will be ejected. So here we can write that it may be possible that all photons in an incident radiation beam, and this beam which is capable to eject electrons, that means if here h nu is given more than the work function, we can say it may be possible that all photons in an incident radiation beam will not eject electrons from the surface. So we can write that in general, number of electrons ejected will be less than the number of photons, total number of photons incident on surface. And this parameter is mathematically accounted in terms of quantum efficiency of the metal surface, which is defined as, here we can define quantum efficiency of metal surface as, this is denoted by the symbol eta, which is written as number of electrons ejected divided by total number of photons incident on the surface. We multiply it by 100 and this will give us the quantum efficiency in percentage. And the reason we already discussed that when the photon is absorbed by an electron and if it loses its energy in the internal collision, it loses most of its energy in the internal collision such that it will not left over with the sufficient amount of energy to overcome the work function. No electron will come out. And when there is a continuous radiation beam, there might be some photons which when absorbed, the electrons may not come out. So we can always say that number of ejected electrons will be less than the number of photons incident. This is accounted in terms of quantum efficiency of the metal surface. So if quantum efficiency is 75%, that means out of 100 photons incident, only 75 electrons will come out from the metal surface. And this is mathematically used only for large number of photons, as it is given for an average value in large quantity of photons incident on a surface.